Let's discuss the situation involving different sized conductors feeding a three-phase motor and address the questions raised. First, concerning the use of different sized conductors to supply a three-phase motor, the National Electrical Code does not explicitly prohibit it, provided certain conditions are met. It is crucial that each conductor is appropriately sized and rated to carry its share of the load current. Each conductor must be suitable for the calculated load. Now, addressing the question of whether this configuration will harm the motor, the answer is generally no, provided that the phase currents are balanced and the voltage drop is within acceptable limits. However, if the conductors are not properly sized, an imbalance in current distribution can occur, potentially leading to overheating of the smaller conductor or conductors. This could damage the conductor's insulation, create a fire hazard, or ultimately lead to motor failure if the current imbalance is significant enough to cause single phasing. It is very important to consider the motor manufacturer's specifications for allowable voltage drop. Generally, a maximum voltage drop of 5% is considered acceptable for the combined feeder and branch circuit, with no more than 3% voltage drop on either the feeder or the branch circuit. Exceeding these limits can cause the motor to run hotter, reducing its lifespan and potentially affecting its performance. When dealing with different sized conductors, ensure that the overcurrent protection devices, such as circuit breakers or fuses, are sized based on the ampacity of the smallest conductor in the circuit, as per the National Electrical Code requirements. This is critical to protect whole conductors from overloads and short circuits. One should consider several factors. 1. Conductor ampacity. The ampacity of each conductor must be determined using National Electrical Code Table 310.16 or other applicable tables, considering the conductor's insulation type, temperature rating, and the ambient temperature where the conductors are installed. 2. Voltage drop. Calculate the voltage drop on each conductor to ensure it is within acceptable limits. Using conductors of different sizes will result in different voltage drops across each conductor. 3. Overcurrent protection. The overcurrent protection device must be sized to protect the smallest conductor in the circuit in accordance with the National Electrical Code requirements. 4. Termination compatibility. Ensure that the terminations at the motor and the panel are suitable for the different conductor sizes being used. Proper termination is essential for maintaining reliable connections and preventing overheating. Regarding the specific scenario presented, where a number 4 aluminum and a number 6 aluminum conductor are used, it's important to assess the ampacity of each conductor and verify that it can handle the motor's full load current, considering any applicable directing factors for ambient temperature or conduit fill. The number 6 aluminum conductor, with its lower ampacity, may be the limiting factor in this circuit. If the calculated voltage drop on the number 6 aluminum conductor exceeds 3%, this would not be good practice and might cause nuisance tripping on an overload. Also, the NEC states the voltage drop should not exceed 5% to the furthest point of operation, so the design must take all loads and wiring into consideration. Utilizing the existing panel with number 2 aluminum and number 4 aluminum conductors presents an alternative, but the same considerations regarding ampacity, voltage drop, and overcurrent protection still apply. You must verify that the existing panel has sufficient capacity to handle the additional motor load without overloading the panel or its main conductors. In conclusion, while using different sized conductors for a three-phase motor is not automatically a violation, it requires careful consideration of ampacity, voltage drop, overcurrent protection, and termination compatibility. Ensuring that each conductor is adequately sized and protected, and that the voltage drop is within acceptable limits, is crucial for safe and reliable motor operation. Always consult the National Electrical Code and relevant industry standards to ensure compliance with all applicable requirements.